Welcome to lesson 11.2. We're going to take a look at probability distributions. But before we do that, let's review some of lesson 11.1. And lesson 11.1, we talked about we can do all kinds of stuff from data sets. And so to help us out, before I actually read through this whole problem, what I'm going to do is open up lesson 11.2. And specifically, I'm going to open up the pre-programmed graphs of calculators. Now, I already have that open right here. So from this link, I'm going to scroll down to AP Statistics and open this Desmos calculator that we'll be using throughout chapter 11. So our problem says here, the average number of minutes the sample of students at Central High School spends using a cell phone each day is shown. Use a graphing calculator to construct a histogram. Summarize the center and spread of the data using either the mean or standard deviation or a 5-number summary. Justify your choice. All right, so I'm going to come over to this data set and I'm going to type in my values. Now I'm typing these all in as x values because that's all we have is one variable type of statistics. We call that univariate. So as I get my last values in here, that's the 15th, 16th. Almost done here. Should be 20 pieces of data here. And when I open up univariate statistics, it should say n equals 20, and it does. So this problem asks us to create a histogram. So what I'm gonna do is click that circle, and then I'm gonna hit this little zoom fit button right there. When I do that, I see my data, and I can tell that this is not symmetric. This is gonna be skewed right. And because of that reason, I would not use the mean and standard deviation. Instead, I would use the 5-number summary because it's skewed. So on this problem, let me write down our values here. The mean, which is the symbol mu, that's what we call that. The Greek letter mu is approximately 30.2. The standard deviation, which would be sigma here, is 14.4. This one's rounded, so I'm going to go approximately 14.4. And then our 5-number summary here. We have a minimum of 10, the first quartile, the lowest 25% of values are 17.5 or less than 17.5. The middle value, the exact minimum, if you place these in order, would be 27.5. The third quartile, that means the lower 75% are 27.5 and below, or you could say the top 25% are 27.5 and higher, and the maximum is 61. Because this is skewed right, we would use this data. The 5-number summary, since it's right skewed, or positive, you could say. Positively skewed or right skewed. So that would be the answer here to number 1. Let's see here. So it wasn't symmetrical. It says it's not symmetrical, so the first 2 are out. Whoops, symmetrical's out, symmetrical's out. It is skewed, but it's skewed so we don't use this data. It's skewed so we'd use the 5-number summary. So it was from 10 to 30, it's a 61 there, yep. For the maximum, the minimum, that's the range. The median was 27.5, and half of the values, that's the first quartile to the third quartile, that's the interquartile, would be from 17.5 to 27.5. So I might have typed in a value wrong in here to get that number off. If you wanted to correct it, you could look through there, and I'm sure you could find real quickly what I actually typed in wrong. Let's see here, 28, 14, 33, 31, 25, 30, 15, 10, 16, 48, 61, 26, 30. No, I think this is just an error here. I think it needs to be a 27.5, or let me check right here to make sure I didn't mess up. Oh, I copied the wrong number. Okay, the number was 40, it's just I copied wrong. So now we can fix this, and our answer should be right along. All right, let's take a look now at number 2. Number 2 says the table shows the frequency distribution of the height of 493 women. Estimate the percentile rank of a woman who is 162 meters tall. If you remember the way we did this, is we found a cumulative frequency and a cumulative percentage. And so 16 women is 16 of the 493. Oh, wait, I'm sorry. The cumulative just means you add up the frequency. So 82 here, this value would be 16 plus 82, which is 98. The next one, you take that 98 and add it to 181, which should be 279. And then I take 279 and add it to 156. So here I would give 435, I think. 435, if I'm doing my math right. 1 carry 1, 8, it's a 3, carry 1. Yep, okay. And now 435, we add 51 more. And here I get 486. You could type these in the calculator if you like, but I'm just doing it by hand here. 486 plus 7, and hopefully that is 493. Okay. So now the cumulative percentage, if you remember what we do is you take that number and you divide it by the whole. So it'd be 16 divided by 493 would give us a percentage of people 154 centimeters or less. So I'm just going to get a new line here. 16 divided by 493 is 3.2%. I'm going to round here. So I should do approximately symbol 3.2%. Okay, and then here I'd have 98 divided by 493. And so I'd change this value from a 16 to a 98, which basically just multiplies that by, well, more than 4. Let's see here, we got 19.9%. Whoops, 19, that's so ugly. Let's try that again, 19.9%. All right, and now let's try the next one, 279 divided by 493, 279 is 56.6%. So we're now over half. Now 435 divided by 493. 435. We're at 80, all the way up to 88.2%. 435 divided by 493. 88.2%. Now 486 divided by 493. Though this is second to last, this will technically be the last one we have to type in the calculator. It's 98.6%. 98.6%. And then the last one you don't even have to type in the calculator because 493 divided by 493 is 1, which means that is equal to 100%. Okay, so we want to know, estimate the percentile rank of a woman who is 162 centimeters tall, so they'd be in this range. So it's going to be somewhere a little bit less than 56%. And the way we did this last time is we came back over here. I'm going to just refresh this now. And we did this as a graph where I put in my X values. So I have 0 at 147 or less. So I'll just add this from 0 to 147. This happens 0 times. And so you would have a 0 and a 0% here. And so what I'm going to do, just to kind of get an idea of the graph, is I'll put in a, I want to put the right bound on each value. So I'll put 147 at 0. And then the next value would be 154 at 3.2%. Then we had 160, and 160's bound has 19.9%. Weight bounded up to 166. We'll take on 56.6. And at this stage, we should be able to get our answer, but I'm going to continue on just so you can see it. 172 is 88.2%. 178 centimeters gets up to 98.6%. And 184 gives us our whole. I'm going to zoom fit this data, and you can kind of see the curve here. If I wanted to estimate specifically at 162, I'd be looking on this line here, which it seems to me it'll be just between, if this is 80, 85, 90, 95, 100, that at 82 we'd be somewhere between 80 and 85. So on my percentages, oh wait, sorry, that's 170, that's 165. Let me zoom in a little bit. So let me zoom in a little bit more so we can get to exactly 162. Okay, here's 162. So it'd be this line. So it'll be somewhere in between these two. 162, I'd estimate somewhere in here around 29 to 30 in there. It's a little difficult to see here. So we really need to get to how we can do a regression. And so what I'm going to do here is take a picture so we can use our smartboard tools and kind of see this once and for all a little bit better. All right, if we were going to try to connect these dots, just do a little connect the dots. If you remember this from, we technically would need to have these curved, but I'm going to do the best I can. Actually, you know what? Instead of doing the best I can, how about I just use some tools here? I'm just going to kind of connect from dot to dot like this. We'll learn about regressions and how to curve this later, but for now, I'm going to do it like that. And this is 170 here. 170, that means this is 165. 162 then would be somewhere in this range right over here. So I'd be looking at over here around 30. So our answer choices, what's a little tricky is that they have two values that are similar, but I know from over here, I would go ahead and say I'd lean towards the 33 as opposed to the 25, just because 25 is way down here. And I don't think that that would be 162. So 33 would be just over, whoops, just over this line. There's 33 right there. I would say that probably better represents the value 62. So I'm going to go with 33% here. 33% when we're at the weight of 162. So I'll go with B.